Today I will present our work, Blind BigBrain Restoration with Generative Priors. It has 5 sections. First, I will introduce the background, our image restoration, super resolution, and the motivation of the approach, the methodology, and the experiments. When we get an image, it's maybe goes through a lot of like a camera blur and noise and like compression and editing and so on. I think the BigBrain image also goes has some of this issue, and so the blind BigBrain image restoration is to recover an even higher quality image from a current one, like maybe from some degradation. Then I talk about some current method, like some method is lining the paired high resolution, low resolution image as priors to guide the work, but sometimes we couldn't get the high resolution image like the BigBrain image. And the second thing is the second kind of approach is learn directly from the low resolution image. And but this kind of approach is couldn't get quite detailed information for the restoration. Another kind of approach is investigate the reference priors, and but limited by the capacity of the model, like restrict its diversity and richness of the detailed priors. And most approach for image super resolution is based on this math model. Like the Y is the high resolution image we want to get. We assume it goes through some kernel convolution based blurring and some kind of downsampling, and also maybe some noisy, and also has maybe some compression. And then the X is the degraded image. For the modeling, some kind of approach is to train the high resolution and the low resolution paired image. We get the image from one camera, and some approach is synthesis the degradations. In this work, we use the synthesis the degradations with this model. And then is the motivation of this work, like a benefit from the development of the deep learning, and we also will use it. And then we combine the GAN-based priors, and also we introduced the rational polynomial interpolation as a kind of a constraint. Then the proposed model has the following components. Is we use the UNet-based network to synthesize the high resolution image to remove the blurring artifacts. And we use a pre-trained GAN as priors. And then this two model is bridged with a latent code mapping and several channel split feature transform, because the reason we use the third bridge them together, because GAN model can produce a lot of priors, but sometimes it has fake information. So we transferred some, and we use and some as make a balance of realist and natural better result. And also we we add a rational polynomial image interpolation. This is a kind of on the whole image. The deep learning based work usually is on patch kind of information. And this days has a paper paper theory. They support the reason I added this constraint. And this kind of like a whole image constraint can force the pixel distribution more close to the real distribution compared with only the patch-based approach. And then this is the flowchart of the approach, and it has a degradation removal based on a unit model, and pre-trained GAN as priors. And we mapped the unit latent information into the GANs each layer, and also we add as I said, the image interpolation approach. And then is the first part is the degradation removal model. It can increase the receptive field for large blur elimination and generate multi-resolution features. And then this is the objective of the model. It has pixel levels whole image reconstruction loss is the fidelity, and also adversarial loss for restoring the realistic texture, and it has a feature-based like a component loss for enhance the details, and some detailed identity, like this kind of identity we can decide by our mask. And then for the training, we, as I said in the introduction, we follow the formal works and adopt this degradation model to synthesize the training data. And then the fourth section is the experiment. I tried it on the 20 macros BigBrain image, and the right is some image from the original BigBrain image, and then the left is some generated image, and then is some result on the one macros image, and then this is the original and some generated image, and this is some zoom in result of the former slice. And to show the performance, we use the gradient histogram to show the distribution of the features, and this is the distribution of the original image, and then this is the feature distribution of the proposed approach. And since the BigBrain, we don't have even more high resolution image. So I use 3 non-reference image quality evaluator metrics. And they evaluate the spatial quality and the naturalness image of the image, also the perception of the image. And all these 3 metrics is the smaller, the better. And the blue color is the original image. And here, the 20 macro, the green is the only use the original polynomial interpolation approach. And then the orange color is the proposed deep learning based combined approach. And then the right is the original, the blue color, and the yellow, the proposed approach. And we can see the image quality improved a lot. And then 5 is the conclusion. We have proposed the framework that leverage the rich and diverse generative price for the BigBrain image restoration. And the price is incorporated into the restoration process with like a channel split and transform to the former layers. Also, a pixel-wide rational polynomial interpolation is introduced as a kind of constraint, and also the results demonstrate the performance of the proposed work. And thank you.